Welcome back, y'all. Today we're going to do solving quadratics. When I go over this, and this concept is going to become back to y'all again during physics, especially with projectile motion. This is going to be an important skill to remember. The first thing is making sure that your quadratic is in standard form. So you'll have a quadratic, and you set it equal to 0, and then you'll solve for the x-intercepts. You may also hear the x-intercepts being, so we're going to solve for the x-intercepts. And that's the same thing as hearing roots, or you may also hear it as the solution. Solutions in parentheses, or the zeros of the quadratic. So these are all the same. And to solve for them, we're going to just solve for x in the given case. Or if you're given a graph, you'll just look for the x-intercept. So if we were to look at this first graph, the quadratic comes down and it touches right at 0. So our solution is just going to be one solution, and the x equals 0. So at x equals 0, we have a solution. Just make this just a little bigger. So we have one solution, and it's at x equals 0. Since it only crosses the x-axis once, for our second graph, you'll notice it does not touch the x-axis, so there's no solution. And then for the third graph, we have two x-intercepts, so there's going to be two solutions, and those solutions are at -1 and at 1. And again, just to kind of relate this to when you go to physics, so you'll learn about something called projectile motion. So pretending that we use a catapult or a trebuchet or some type of cannon, anything that we're going to launch an object, and usually an object follows a parabolic motion, so it has this curve in the sky, and then you'll actually be using this to find out at what time it's at the ground. And when it's at the ground, there's actually always going to be two solutions. One is at 0, where you start, and the other one will be at some unknown time, and that kind of depends on the speed, the velocity, where you're located, things like that. And then the gravity of the situation, that's usually the acceleration. And typically for projectile motion, you have the assumption that you're on Earth, and that's just a whole nother situation. But yeah, you will see this again where you're going to have to use the zeros or the x-intercepts to help you find out time at where a projectile is located. So for the next one set, we can solve each equation by graphing the relative function. So I'm going to just use a different color border. So it's kind of hard to see, but there is ooh, that was not very good. The y axis and the x-axis. X, y, and if I was to graph this, so x minus 1 equals 0. You could use Desmos, but so to locate this, we're going to go right here. It's a parabola, so let's go like this. You can put this in your calculator or the Desmos, and you'll see that it crosses at 2 points. So because it crosses the x-axis at 2 points, that means we have two solutions. and those two solutions are at x equals positive and negative 1. At positive 1 right here and at negative 1. Just to kind of show that. So to show that, I'm going to bring up Desmos real quick. Type in, so x squared is 1. And you'll notice two spots, 1 and negative 1. I want to graph the next one, so we have 2x squared plus 4. So you'll notice up here, just kind of as a reference, so the constant, you notice the negative 1, we plotted all the way at negative y at y negative 1. For here, for plus 4, we plotted at 4. So that's kind of determines where your y-intercept is for the quadratic equation. So I'm going to put the calculator away and I'm going to just graph that real quick. So for this case, there would be no solution since it does not cross the x-axis. Go ahead and fill that in as no, oh, whoops, this, no solution. Reason for that is if I was to graph this, I should bring that down a little bit. So I'm going to bring my x-axis down just a little bit because otherwise I'll be off the page. So graph a little bit different color. 1, 2, 3, 2, 3. So it does not have a solution. And then for the next one, if I was to, in fact, I'll just go ahead and make this. So the first thing is that we can't graph it until it's in standard form. So because we have this negative 16 on the right, we need to move it over. So what I'm going to do is I'm going to do that real quick. So we got x squared minus 16 equals negative 16. Let's write it in standard form. So we're going to add 16 to both sides. Cancels, and coincidentally this cancels out as well. So we have x squared equals 0. Now in this case then, at this type of graph, it doesn't have a y-intercept. Well, it does have a y-intercept, and the y-intercept is at the origin. So 0, and it's just a typical x squared graph, so it's going to go up. And so this only has one solution, and that solution is at x equals 0. Alright. I'm going to move to the next page. So now they want us to solve by using square roots. So we need to find the roots for each one. To do that, we're just basically going to solve for x. So at least in this case, so we're going to solve for x for all of these on this page, like that. So we have 3x squared minus 75 equals 0. So it would add 75 to both sides. Cancels. I'm left with 3x squared equals 75. I'm going to divide by 3 on both sides. X squared equals 25. I'm not done at this point because I still have an x squared value, so the opposite of squaring is the square root. So take the square root of both sides. And this kind of goes back to the beginning of the year when we're dealing with roots. When you take the square root of something, there are two roots. One is positive and the other is negative. So our solution is going to cross at 2 points. So there's going to be two zeros. and those zeros are positive 5 and negative 5, but you'll see it written as plus or minus 5. So this is our answer, and I'll just write it over here. So this is plus or minus 5. All right, for the next one, this one's a little bit quick, so we don't have to worry about a coefficient like we had on the top. So we want to solve for t. So I'm going to add 25 to both sides. This cancels. I'm left with t squared equals 25. Take the square root. And again, when you take the square root, you get two roots. One is positive and one is negative, so it's plus or minus 5. And this should let you know, remind you as well from the beginning of the year, because remember, 5 times 5, so positive 5 times positive 5 gives us 25. And negative 5 times negative 5 gives us 25. So both of those are the roots. And again, just to kind of bring up, when you're dealing with physics, there's going to be times too where you get your answer, your roots is both positive and negative for time. And you'll know the correct answer for time is going to be positive because you can't go back in time. Again, that's just kind of something you to think about later, a couple years down the road or what have you. All right, so I'm going to do one more. What I'd like you to do on the next two, though, is to pause and then try on your own, and then unpause and see if you get the right answer. I'm going to work through these quickly as you do that. So the next one, solve for n. So we're going to subtract 12 on both sides. Minus 12 is going to give us 0. We're going to divide by 3 to cancel out our coefficient. 0 divided by 3 is going to be 0. And then we're going to take the square root. Square root of 0 is just 0, so n equals 0. So we just have one solution at 0. And for the next one, we're going to subtract 32 to both sides. 2g squared equals negative 32. Divide by 2, divide by 2. You're left with negative 16, and then we're going to take the square root. So we don't know this yet, but as of for this year, when you take the square root of a negative, it's just going to be no solution. This is an undefined situation for y'all this year, so there is no solution for this. All right, go to the next page. Okay, so this is when we have quadratics. You can solve the quadratic equation by finding using the zero product property. The zero product property for every real number a and b, if a times b equals 0, then a equals 0 and b equals 0. So what this is basically saying is that if we can at least solve for one of these roots to be 0, so if we can solve for this pair of this binomial to be 0, we would be left with 0 times x plus 2, and no matter what this x is, 0 times anything is just going to be 0. And the same would be for the same cases, whatever this x is, as long as whatever we put in for x cancels out this binomial to be 0, 0 times that is just 0. So if we can get one of these roots to be 0, that's one of the answers, and then doing it for the opposite as well. And how you do that is that you set each binomial equal to 0 and then solve for x. So if I was to solve the first one, we factored out our quadratic to have 2x plus 3 and x minus 4 as being in our solution. So now we need to find the zeros. So to do that, you're going to set 2x plus 3 equal to 0 and then solve for x. And then we're going to solve the next binomial to do the same thing. So we're going to first subtract 3 on both sides. 2x equals negative 3. What do we need to do next? We need to get rid of the coefficients, so we're going to divide by 2. Because that's the inverse operation. So we're left with x equals negative 3 halves. So this is one of the solutions. We're not done yet. Okay, because we were able to find out if we turn this to 0, we'd still get 0, so now we have to do it for the next one. So we need to solve for the next root. X minus 4 equals 0. And just solve for x, so plus 4 plus 4. So we're doing the inverse operation. Negative 4 plus 4 cancels. So we're left with x equals 4. So our two roots for this quadratic after we factored is x equals negative 3 halves and x equals 4. Now if you'd like to see that, what we can do is, I need to just bring this up over here. So I'm going to clear this out. So parentheses first. 2x plus 3 times the quantity of x minus 4. Alright, so this is, if we were to multiply these together, you would have a quadratic, and you could have graphed that quadratic, but since it was already factored for us, we can go ahead and find out where its roots are by setting each one equal to 0. So if we did our work right, we had x equals negative 3 halves and x equals 4. So let's check. A root at x equals 4, there's 1. And then negative 1.5, which is negative 3 halves. Solving algebraically for the roots after you factored is really good because it can be more accurate. The most common example is, if this had been negative 1/3, most of the time, if we were to have that as a decimal, which is negative 0.33333 repeating, a lot of individuals will just put 0.3 or 0.33 instead of putting the repeating mark. So this is just a little bit more accurate with having solving it to be a fraction. I'm going to clear that away from the screen. Alright, so for the next one, it's not factored yet, so we can't solve for zeros. So the first thing we need to do is we need to factor. Alright, so looking at this, x squared plus 6 minus 42. Remember from factoring, if you end with a negative, right, you're going to have a x plus, well, so it might be a different coefficient, and an x minus. Luckily, our coefficient's 1 on this, so they're going to be just 2 x's. But you'll have a positive constant and then a negative constant. So we need to solve for those. So we need to find out what are factors of 42, factors of negative 42, that add up to be 1, right? So what are our factors of 42? We have 7 and 6, and we want, one of these has to be negative, and it has to add up to 1. So if it adds up to positive 1, which one of these would have the negative on it? Well, if we want to be more positive, then 7 would have to be positive, and the 6 would be negative, because 7 plus negative 6 is 1. So now we have our factors, so x plus 7, x minus 6. So these would be our factors, but now we need to find the roots. So to find the roots, remember we're going to set each factor equal to 0, which I'm going to do over here. So x plus 7, 0, and x minus 6 equals 0. So we're going to subtract 7 on both sides for the first one. X equals negative 7. And we're going to add 6 to both sides. And we get x equals positive 6. So we have two solutions, one at -7 and one at 6. If I wanted to verify that, just bring that up real quick. So x squared plus 6, I'm sorry, plus x minus 42. Let's look. So we got a -7 and a positive 6 for our root. So we're good to go. See that? Okay, just making sure. I'm going to clear that. Get rid of the calculator. Alright, so what I'm going to do here is I'm going to end the video here, but I'm going to have a second part. What I'd like you to do is at least solve for the next two, or I'm sorry, the next three on your own, and when you come back, when I come back, then we'll work through those other three and finish up with the quadratic formula to help you with finding your roots as well. Alright, so I will see you back later, and I'll talk to you soon.